In this video, I'm going to show you how you can use JMP's design of experiments features to uh, already set up a lot of the designs that we've looked at and maybe give you designs that don't quite meet some of the criteria that we've considered. So you actually don't need to bring any data when you open JMP. You just want to go to the DOE option up here, and you have all of these different options that JMP can do. So JMP can actually automatically give you a table of a full factorial design if you wanted to, including replicates. So that's a little bit faster than having to type out all the columns yourself. And we can even do some screening design. So for example, for a confounded block design, you can use this option. But I want to look at the custom design feature, which kind of gives designs for any sort of scenario. So if you click on custom design, this window pops up and it asks for you to input responses. So for right now, we're not going to worry about that because we just have some arbitrary response y, and the goal doesn't really matter for what we're doing right now. What we care about is adding factors. So let's consider the case where we're trying to do a incomplete block design with 7 treatments, 7 blocks of size 3. So this was a case where we actually saw that a balanced incomplete block design exists. So let's see if JMP can actually find that for us. So we need to add in here a blocking factor and a categorical treatment factor. So I'm going to go to add factor, add blocks, and then it says how many runs you need per block. So it does 2, 3, 4, and 8 by default, but if you had another scenario, you could just click other and say what you need. So we're going to do 3 runs per block in this case because we have a block size of 3. So notice automatically it doesn't say how many blocks you're going to have. It says you have at least 1, and it's up to you to tell it how many blocks you want, as we'll see in a second, by saying how many total runs you're going to perform. And so let's change this name to block, just so we remember that's what that is. And now I'm going to add a treatment factor. So I'll just go to categorical and say I have 7 levels. And I'll just rename this, let's see, treatment. And so by default, the labels are going to be L1, L2, up to L7. If you want, you could just call it 1, 2, 3, 4, 5, 6, and 7. You actually need this labeling for that SAS macro code that I'll show in another video to work. So we said our number of treatments, we said what our block size is, but we haven't told a JMP how many blocks we want. And so if I click continue, down here it says the number of runs, and it says by default it's going to suggest 18, and that gives us 6 blocks when we do that, and that's because 6 times 3 is 18. So by changing the number of runs, we're going to change the number of blocks because it knows it has to be blocks of size 3. So if I change this to 21 total runs, 21 divided by 3 gives me 7, and so that's how I get the same number of blocks and treatments. Now when it comes to this part right here, where it says estimability, for what we're doing, this isn't terribly important. But if you had a factorial treatment structure, then you could have main effects and two-factor interactions inside this model. And you could just do a click on necessary and go to if possible. And so this is one way of getting JMP to emphasize estimating main effects over two-factor interactions, which we'll see maybe later on in this semester. So then we click on Make Design, and right now what it's doing is it's performing a design search algorithm to find the best block design, and it's doing it with respect to the D criterion, as you can see right here. And so it does take some time for it to be able to compute it because it's searching through a bunch of different possible scenarios, but not too long. So here's the design that JMP tells us is the one that we should use. And so here it has blocks 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. And these are the treatments that it would put in each block. And so if I wanted to resort this with respect to block, then I can right-click across block and say sort by column, and then I'll click block, and then it does it in a different order, but we can see that this is the design that JMP recommends. And I believe that it's actually, oh no, that's not quite right. But I think this is a design similar to what we saw, and it looks like this is probably going to be a balanced incomplete block design. As far as checking that in JMP, it's not exactly obvious how they do that. It's not a feature that they have in JMP. But one thing you can do is click on Design Evaluation. And then you can then look at is something like a color map on correlations. And so what this is looking at is how the columns of your treatment matrix compare to your block matrix. This is a little advanced for some of you, but ideally what we would like to see, I believe, is that we want the correlations to be 0 between the treatments and between the treatments up here. The treatments won't be totally orthogonal to the blocks because not every treatment appears in every block. If I created the same sort of picture where I had where I had a complete block design scenario, then everything would be 0 because every treatment appears in every block the same number of times. But that's not going to happen because treatment 1 is only going to appear in some blocks and not all. I believe that when everything is 0 right here, that I'm not exactly sure, so sorry about that, but this is not exactly the best way to tell if this is a balancing complete block design, honestly, is to input this design into that SAS macro, which is part of your another video and part of your homework, to see if it's a balancing complete block design or not. This matrix is useful when we're looking at factorial effects. So if I want to output this design into a data set, you just go down here and then you can do the run order. So this is actually nice because it'll actually do the randomization procedure for you. It does randomize within blocks, so you have to randomly assign what you're calling block 1, 2, 3, 4, up to 7, but it does do a randomization within the blocks automatically for you. So if you click Make Table, it gives you this kind of stock SAS or JMP data set, and you can use this to fill in data yourself. And what's also kind of nice about this is once you have values of Y, if you go to Analyze and Fit Model, it's automatically going to give you the model that you said you were going to use to analyze it. This is why for that one factorial data set I gave you for the unreplicated factorial experiment, that it gave you a model up to 2-factor interactions, and that was because I generated that design using JMP. So that's how you do an incomplete block design for a general treatment structure, but let's say you wanted to use JMP to try to create that block design using confounded factorials. So I'm not going to save that. So you could do the custom design feature to try to get it to do it, but JMP is actually already capable of creating those designs using the screening design feature. So I'll go to Screening Designs, and a very similar window pops up like before, but it doesn't let you add arbitrary factors. It only lets you add continuous, discrete numeric, or categorical. So let's say we want to add do a 2 to the 5 experiment and introduce some blocking inside of it. So let's do 5 factors, and I want them to be each have 2 levels. So I'll go to discrete numeric and do 2 levels. Automatically, it's going to do this kind of -1 and +1 sort of coding for the values, but you could change that if you wanted to. And then you click Continue, and it gives you 2 options. It says choose from a list of fractional factorial designs, or generate orthogonal or near orthogonal designs for main effects only. So this option down here is useful for when we have kind of unusual non-textbook examples of designs, and it can use the design search algorithm to find a fairly good design. But we're going to choose the list of fractional factorial designs. I click Continue. And so we haven't looked at fractional factorials quite yet, or Plackett-Berman designs, but if you look down here, it says full factorial, and it also allows you to do block designs of different block sizes. So the number of runs is always going to be 32. So this first one would be a design with 2 blocks of size 16. This would be a design of 4 blocks of size 8, 8 blocks of size 4, and then 16 blocks of size 2 is what this would allow you to do. So if we wanted to do 4 blocks of size 8, we could just pick this design right here, click Continue, and it already knows it can construct that design. It even also tells you some of the aliasing. It won't show much aliasing to start out with because usually JMP will focus on just aliasing or bias between or confounding between two-factor interactions. So you won't need to worry about that. But if you click Make Table, here it's giving you blocks based off of plus or minus ones. So it won't tell you immediately which factors it's confounded in this analysis, but you can check that back here by going to Design Evaluation. Not exactly sure where that option left you. It should give you the way of how it constructed the design. I'm not sure where that went. It was there a second ago, but it does tell you that it's confounding higher order interactions besides two-factor interactions because it said that all two-factor interactions could be estimable. So you don't have to necessarily use all of the construction methods I've taught you because JMP can do it for you, but it's good to know how these things are constructed, and so JMP can do that for you.